Hello everyone. Today we will be talking about out-of-memory errors step-by-step diagnosis guide. Let's start by understanding shared memory in NPS. NPS host has about 1.7 GB of shared memory pre-allocated during NZ start. Spoos have between 1.7 GB to 2.4 GB shared memory on each blade. Size depends on NPS model. This shared memory is used for inter-process communications. Statistics of shared memory, which is total, available, or used, can be determined using following commands. On host, ncsq memtable-sys. On spoos, ncsq memtable-all can be used to get that information. If for any reason this allocation fails, query will fail with out-of-memory errors. There are two types of out-of-memory errors because we have two different shared memories: host-based out-of-memory error and spool-based out-of-memory error. The error message helps us understand what type of out-of-memory we are dealing with. Let's look at some sample error messages. For host-based out-of-memory error, we would always see words such as cross reserves or reserve exceeded. These are purely host-based out-of-memory errors. Whereas spool-based out-of-memory error, with error message, we see a number followed by out-of-memory. That number represents how much bytes it was trying to allocate before it ran into an error message. Let's look at how to interpret the output from ncsq memtable-sys or -all output, because this is very important for our understanding to diagnose this issue. So if you look at, there are two sections. First is the summary section, and at the end it has details of the total available memories. So the first section tells most two columns used are how much memory is used, under what mem type or mem name. It gives individual allocation. Whereas at the end, it gives the summary of what total memory snapshot looks like. Region total size is the total size of shared memory. Region available size is how much memory is available at that point in time. Region in use size is the total memory that is currently being used. Note that be it on the spool or on the host, output is very similar. Thus, when you are looking at type of out-of-memory, our analysis is based on the same lines. We have other table for our diagnosis of out-of-memory errors. ncsq memtable output gives you overall summary, but VT memory new can give you ability to drill down to a particular query or a particular session. In PDA Netezza's virtual table, VT memory new stores every allocation made by every process or query, either on the host side or on the spool side. Entries are made in round robin fashion, so you will only find most recent entries. Querying this table at the time of the error may give you a lot of clues in terms of identifying which session was responsible for consuming how much memory and under which mem type. Here are the details of the table structure and its importance of the columns. Please go through and have familiarity of this table before moving on customization. What to look when you are working on out-of-memory errors? First, try to understand the nature of out-of-memory by answering following questions. Is it always one query or similar type of queries failing with out-of-memory? This means we can look at PG log and identify which queries are failing at corresponding plant files. If it is always one query, then we should analyze that query to understand why. Are queries failing at random? This means the system was running low on shared memory and requesting allocation failed. ncsq memtable should help understand what was the available and or used shared memory on the host or spool depending on the error message. And this could mean two reasons. One, either system was very busy that whatever was available was so little that it cannot satisfy the new incoming jobs. The other reason could be that whatever memory has left is so little that all new jobs coming in are causing it to fail. Imagine you have a periodic ncsq memtable snapshots and that you plot a graph of region available size versus time. We will see two different patterns. Root cause 1, on a busy system, you would see that your available shared memory was fine, and as the system got busier, or at the time of the error messages, you have very few or very little shared memory left. Important thing is to note is as the system became idle, your available shared memory came back to normal. Whereas in the situation where it is leaks, your available shared memory keeps reducing as time passes. It never goes up, and it reaches to a point where all jobs starts failing. On a busy system example, let's look at what you would diagnose, what is the solution, or what are the best practices. As we see, if we graph for each available size, we would see how much is available, and when the jobs fail, how much was actually available. Drilling down for that particular snapshot, we would know under which name most of the allocations was made. Question that comes to mind is, what jobs are causing these high memory allocation? Solution: identify which job or query were running at the time of out of memory. Once we know what is causing or contributing high memory utilization, we can see how these jobs can be executed apart from each other to prevent such situation to happen. How do I resolve these issues when system is busy? Look at the active queries. Does customer have too many active queries at the time of the failure? Does customer have too many queries which are host-based operation? Does select queries which are at the end of completion will spool a lot of data on the host, which will consume a lot of shared memory? Load unload jobs are mostly host operation, which requires a lot of shared memory. If client is slow in sending or receiving the data, we can see memory allocated for extended period, causing other jobs to fail for during that period. Solution is to reduce such jobs that can be run in parallel using development features. Does customer have some long-running active or idle sessions open for days? Can we start aborting such sessions that are open for days using the session account? Is any bad plan which is processing on the host consuming a lot of shared memory? Identify such query or plan which may be need to review by the customer or by support. Let's look at some of the sample queries that can be used to query VT memory new table that we looked earlier to see how it can help us to identify our individual session or plan files. Here are some of the sample queries. Restriction hardware ID equal to 0 means we are looking at some allocations on the host side, whereas hardware ID not equal to 0 means we are looking at processes some on the spool side. If you can target specific spool by specifying the spool hardware ID, you can play around with above queries to add more restrictions and change the query as you need to obtain the results and drill down further. Let's look at the example where it is a memory leak situation. What would be our diagnosis and what would be our workaround? If we do identify that there are no active or idle sessions on the customer's machine, still the memory utilization have been low in such situations, memory has leaked over time, and that only way to fail is database restart. So when we graph for each and available size, we would see only a few megabytes left. And when we look at the detailed section, we would see find which name that most of the allocation is based. The question that comes to mind is, why hasn't this memory failed even when system is running few or no jobs? What jobs or queries causing these leaks? Let's ask customer to restart NPS, and at the start, of course, memory will be reinitialized and gives customer immediate relief to their problem. Before we start, make sure to collect all the diagnostics information for our analysis. How do I resolve issues in memory leak situation? Once you have seen a pattern where memory leaks are observed, available shared memory gradually increasing, we will take the following steps. Identify which mem type or membrane utilizes most memory. Using VT memory new table to determine which bits or plans utilizes most memory blocks under membrane. For example, we look at this particular query. Once you know possible culprit, specific set of queries causing memory leaks, you can run such queries on customer's machine. Of course, when it's idle, to confirm it's causing leak by taking before and after memory leaks snapshots, we can use SDEF to compare these snapshots. If you do decide to raise it as a defect, make sure to collect necessary logs and files, key items, and table snapshots for engineering investigation. As we can see, we need one of the important thing is periodic table snapshots, and times we do need plan files and all the other relevant information. We created a monitoring script that can ease us to collect all the required information. One can use monitoring script with the appropriate option to collect the required information for diagnosing the issues. Snapshots every 2 minutes help us understand what type of out-of-memory customer is hitting and what appropriate action needs to be taken to overcome the problem. Whenever help is needed via CMR, make sure to provide relevant information via monitor.sh script. Important note: do not run host boom and spool booms together, specifically on larger machines. Running these commands put a lot of pressure on this manager process and on shared memory and may cause unforeseen issues. Here are the sample entries in contab that one would make to collect relevant information. For post-based, here is the entry. Make sure to collect all the relevant information before opening the CRM. For spool booms, here is the control entry and here is the log information that one will collect. Other diagnostics tools that is available for engineering analysis, one can use code dump using CliQA-abort. The proper command is CliQA-abort 6, no crash, to be executed on customer's machine. Any query that would fail with out of memory will generate a code dump file just before the error message. It will generate debug code in case of host-based out of memory error. It will generate spool code in case of spool-based out of memory error. This code file can be used by engineering to determine what shared memory allocations were made at the time of the error. In case where shared memory usage is high and everything else fails with out of memory, one can manually generate code file using kill-44 bit of the debug dispatch in case of host-based out of memory error. NCSQ dump and go identify a particular spool and a particular bed in case of spool-based out of memory error. Hardware ID should be the hardware ID where we are getting out of memory errors or is running on shared memory, whereas bit can be any process on the spool. We just need the dump of shared memory. Note: CliQA command is only available in certain releases, and on some versions it causes NPS to restart. Used as a very last resort where nothing else help. Analysis of code files for shared memory allocation is also a skilled process, and only few in Netezza engineering have knowledge of this. So going this route means your analysis may take longer time. Any questions? Please ask us on Slack channel. Thank you for watching.